afternoon and welcome to iReport. I'm here today at Albion College with Timothy Hawking, the youngest son of Stephen Hawking. He's with us to tell, from an inside perspective, a little bit about his father. Welcome, Timothy. How are you today?
I'm doing good. How about you?
Doing great. So can you tell me a little bit about your father's upbringing?
Well, my father was born on January 8th, 1942 in Oxford, England. He lived in North London until he was about 8 and then moved to St. Albans. He attended Oxford University and he had an interest in mathematics, but they didn't have that field, so he instead studied physics.
Oh. So he must have been very hardworking?
He didn't study all too often, but he was just so naturally smart that he was able to get through school easy. He finished school in 3 years and with honors.
That's incredible. What did he do after Oxford?
He got his PhD in cosmology at Cambridge University, and he continued his research there too, and teaching.
Your father has had a huge impact in astronomy despite having amyotrophic lateral sclerosis. Can you tell me a little bit about ALS?
ALS, or commonly known as Lou Gehrig's disease, is a neurodegenerative disease that affects nerve cells. When motor neurons degenerate, a person loses control of muscle movement.
How do you think that impacted his life?
Well, my father was diagnosed at a very young age, shortly after his 21st birthday. He was only given about 2 years to live, but he was determined to make the most out of his life. He realized that he needed to work very hard to accomplish his goals and his professional career, contrary to what he was used to doing. So in a sense, his disease sort of pushed him to do more amazing things.
What about his life outside of science?
There are always difficulties people with ALS face. He didn't let this define him, though. He married my mother and had 3 children, my sister, my brother, and I. He also married a second time, too.
The findings of your father answered a lot of questions in science. He's best known for Hawking radiation and the Penrose-Hawking theorems. Can you explain what the importance of these are?
Well, I'll start with Hawking's radiation. Do you know what black holes are?
Yeah. Yes, a black hole is a bottomless pit in space where nothing can escape or be observed once it has fallen into it.
Yep, that's correct. Hawking's radiation is radiation that evaporates from a black hole, with the radiation source being gravitational potential energy, which is GPE. And GPE is the energy of an object because of its position in a gravitational field. So basically, my father's research concluded that because of this continual emission of radiation, black holes shrink over long periods of time.
I thought that nothing can escape a black hole. So how does this work?
To understand this, we need to define virtual particles.
To clarify, a virtual particle is one that exists and disappears so quickly that it cannot be directly detected?
Yeah, so a virtual particle is made up of electrons, which are negatively charged particles, and positrons, which are positively charged particles. Virtual pairs when electrons and positrons destroy each other before they are detected. When this happens near the event horizon, the boundary between a black hole and the outside universe, real particles form. The energy source in the event horizon is a gravitational potential energy, which I previously explained. When real electrons and positrons destroy each other, real photons are radiated into space, giving an observer the appearance of radiation of the black hole.
Wow, so black holes don't last forever. Does this relate to the Penrose-Hawking theorems?
Sort of. The theorem relates in singularity, which is a part of a black hole, but does not have a connection with radiation.
And a singularity is the place at the center of a black hole where gravity pushes all matter into an infinitely small and dense point.
Correct. So Penrose and my father's theory of singularity said that the universe had to have started in singularity, like the Big Bang, and stars collapsed in singularity.
How did they come to this conclusion?
They used the general theory of relativity determined by Einstein, which says that time and space are in one single continuum. Basically, what we need to know is that massive objects in space distort space-time, which we feel as gravity. His equation, R equals GE, R being the number representing the distortion of time, and G being the gravitational content, and E being the energy of the object, better describes the theory.
So how do these all relate?
Well, you see, a black hole has a huge curved spacetime, meaning the distortion, or R value, is great. with more of distortion means that there is a great gravitational constant in the black hole. Singularities in the black hole are infinitely small, hot and dense. Therefore, the Big Bang is believed that to be the first singularity expanding and cooling, making the universe what it is today.
That really is a huge finding in science. But unfortunately, it looks like we have run out of time. Thank you for meeting with me today and talking about your father. He definitely has had one of the greatest impacts in the cosmological world.
Yep. Anytime, thank you.